let's try to look at COPASI.
Okay.
This is a very brief thing only, and we assume that you don't have that installed. If you have it, you can of course already do it with us. Just want to show you the environment. This is a free toolbox, a free software that you have to download and install on your computer. Once you have it installed, you click on it. It opens similarly in a user interface that is divided into two parts. Left part for navigation, right part for putting in specific values in specific tasks or model parts of the model. So without doing too much of an introduction to COPASI here, I just want to highlight you that in the top toolbar on the top of your screen, you have next to the COPASI information, you have the possibility to open a file. So what we don't do, we don't open the file, but we import it. We need to import it because COPASI needs to understand what format it is, and it will check, if you use the import functionality, it will check the format and automatically display. So import SBML, because we know we downloaded an SBML format. It will ask you which model do you want to import, and we click on just the one that we had selected from the Nielsen paper before. If you do this, you get a very complicated warning, which we ignore for this moment. We click OK, assuming everything is OK. And you can always ignore warnings. They are not errors. They're just telling you something that is maybe needs attracting attention, but you can always ignore warnings. So this already has imported the whole model, and we can't really see it right here. But if you expand on the navigation bar under Model and Biochemical and go to the reactions, you will similarly as in the SimBiology will get an overview of the reactions that are there. And you can see that somewhat further down there's a parameter overview. And if you click on this, you will get the initial concentrations of all metabolites plus the parameter values with their name and their mathematical numerical value displayed and made available for changing them. Okay, so we don't want to change them, but we want to see how easy is it actually to run a temporal a time series as we did before in SimBiology.
Well, there's this tasks tab again here.
Right, so there's tasks now, again, similar to SimBiology. Which task could you choose?
Time course?
Time course, so it says not simulation, but it's called time course here. If we select this one, we say at the top of the specifics that time course is what you have selected. So we make the same change that we did previously in SimBiology. We make the duration 600. In this case, it's correctly displayed as minutes rather than seconds. So we want our longer period simulated. We leave everything else as it is. One specificity, now it has, after you have sort of entered this value, it has automatically changed the interval size below the duration. If you go to that box where it says interval size, and make a bit of a smaller interval, say 0.1 or I don't know, it doesn't really matter, but to have not too big steps in time for the simulation to jump forward and leave everything else as is. Now, a peculiarity about COPASI is you have to tell the software what you want to see, what you want to get as a result.
Okay.
And there's various opportunities. You can have it stored in a text file, you can have it stored as a table, you can have a graphical image, you can have a file saved to the desktop. We want to just see an image as we did before. So if we use in the bottom right corner the output assistant, click on it and use the first option where it says concentrations. Under plots, the first option is concentrations. Click create. Sort of select this output, it means plot all concentrations.
And then click run.
And now we are ready to go, and in the specifics window on the bottom on the left side, it says next to reward, it says run, which is the same as the green button in MATLAB. If you click on the run, you will be able to see that. You'll see the output of the simulation, and you can see it's fairly similar to what we have before. If there are minor differences, it's possible, and that would then be a matter of how is the simulation done internally. This is something for which we are not yet prepared to look into it, but of course we'll have this capability within a few weeks. Okay, let's just close this window for a moment. I should mention that COPASI has been designed specifically for biologically trained people who want to run simulation without having to bother about any mathematics or any coding. So if you are one of those, or if you know people who are one of those type, please refer them to this environment. It's extremely good when it comes to reaction kinetic modeling. It's harder to use if you have physiological modeling or maybe spatiotemporal modeling for imaging. It will be a bit more complicated. You need to know more how to access the internals of the model and actually be able to change code inside.
Can I just add that COPASI, unlike MATLAB, is free. So there's a free version of COPASI.
Unlike MATLAB, it's free, costs you nothing. It's across platforms, so any platform, Windows, Linux, and OS X, it will run. And it's being constantly updated by groups in Blacksburg in Virginia and at the University of Heidelberg. So there should be also expert support if you need something, if you have some problem that you cannot solve. They offer tutorials and individual bug fixing if that's necessary. Okay, let's look at finally at a functionality that is there, which is quite nice under steady state. So if you go above time course and the tasks, there's a functionality called steady state. Actually allows you to run a simulation that will try to calculate the steady state from a mathematical point of view. Because what we saw here is we haven't actually seen a steady state, right? We have seen some oscillations that seem to fluctuate around a steady state that is the mean value of this oscillation, but we haven't actually got this numerical value of this mean. You can get this if you are in this task called steady state, and if you just press run.
Okay.
What you will get is a meaningless output, because steady state doesn't give you a temporal profile of it, so you just click and make that window go away. But you have now a table with all the steady state values of this model. So you have the numerical values of, in this case, how is it expressed? Millimoles per liter in millimolar. You have expressed for each of the metabolites the numerical value, the quantitative value that is predicted by this model, and which is what you can then take and compare against experiments. And ideally, this is always what we want. We want to know what is it, what I should look for in my experimental data. So you can look for the nodes, which are the metabolites on the left side. You can look for the enzymatic processes or the catalysis, which is under reactions. These are the sort of kinetics that go into it. And you get further information like the rate, which means flux through, how much is actually processed by any of the enzymes that is converting one of the metabolites that you have here at a given point in time. So all of this with a lot more possibilities, like looking at sensitivities, looking at robustness, looking at network motifs, and so on. All of this is within a very few steps of adjustment available in COPASI. Okay, that concludes the section on COPASI. So we recommend it to at least look at it, know about it, and maybe at some point you really want to have a look and recommend it. Specifically, if you have your model downloaded from the biomodels database, as you saw, you can just import them directly, use them in a straightforward manner.